Finally, we can move on to GitOps deployment. If you're just joining us, we've done a lot in the last 7 videos. All previous videos were based off of following along to scripts in my Proxmox K3s GitHub repository. In this video, we'll be following along to a different GitHub repository called Rancher Fleet. But here's a quick recap of what we've done so far. We've set up a nested Proxmox instance, then customized this Proxmox instance with a separate user and SSH key. Then we set up 9 Ubuntu VMs based off of a template. Then we deployed a Kubernetes K3s cluster within 8 of those VMs. Then we set up a UI to manage our K3s cluster. And then finally, in our Kubernetes cluster, we deployed a workload using Nextcloud. This Nextcloud instance can host files like a Dropbox-like or Google Drive-like site, and it has persistent storage with a MySQL MariaDB database. In the last video, we demonstrated certain dependencies in place within script 6 when deploying Nextcloud by underpowering the system. I showcased some of these failsafes within the script. Now with all of that out of the way, our nested Proxmox host is set back at 8 cores, and then each one of our VMs is set back to 2 cores each, and now our worker nodes have 4 cores each, so we're back to the original setup. Now we've saved the best for last. We'll be deploying a version of script 6, but this time adapted to run in a GitOps manner. Continuous delivery pipelines, also known as CI/CD pipelines, are a huge buzzword in the world of DevOps and cloud development, and rightfully so. It's a pretty interesting concept in that if you push code to a repository like GitHub, your infrastructure picks up on those changes and automatically builds what's defined in your repository. Now, a prerequisite to this video is that you need Git installed on your computer so you can push code to a GitHub repository. You'll also need a GitHub account created. Let's assume you already have both. We'll be creating our own new repository, but first let's review what's already in my GitHub. To connect Rancher, the UI that manages Kubernetes, to our GitHub, we'll be using a component of Rancher called Fleet. There are many continuous delivery tools out there, but we'll be using Rancher Fleet since it's something that already comes with Rancher. And I'm essentially following along to a tutorial from the YouTuber Jim's Garage on creating this connection. Now we can go to our GitHub and add a new repository. I'll call this repository New Repo. And in this case, I'll make it private. We can make it publicly viewable later if you wanted to showcase something. Next, we need to generate a way for Rancher to access this GitHub repository. We'll click our profile here in the top right corner, and then go to Settings, and then scroll down to Developer Settings, and then we'll create a personal access token, which will be a type called a fine-grained token. We'll generate a new token here, and it does have an expiration date for security. I'll give it a name like New Repo Token. And since we made our repository private, we have to select it here, and then we have to give certain permissions. Now adding these permissions may take a moment, but I'll quickly go through them. We just have to add read-only access to anything that offers it. And if it just says read and write, we'll skip it. We also have to add it here. Again, you can skip things that say read and write. And generate token. Now we'll copy this to Notepad, as this is the only time we'll be able to see this token. Next, we can go back to Rancher, and if you haven't already, you can click the sailboat icon, which is Rancher's Fleet. Now, I'll scoot my browser a little bit this way so you can see, but the default it picks is Fleet Default, and we actually need to pick Fleet Local, so that way it will talk to our cluster. Confusing, I know, but that's what we have to do. Then we'll click Get Started, and now we're on the Git Repo section. We can put in the same name we made for our repository, which will be New Repo. Then we'll click Next. Then we'll go back to the new repository we made, and copy that URL. Then we can go back to Fleet and paste that in here. And this is important. Fleet defaults to master as the branch name. We need to change this to main because that's what GitHub uses. Now that those are the same, we can click next, and we'll leave this as the defaults. Then click next, and our authentication will be with an auth secret. The username will be the email under your GitHub, and the password will be our auth token. I'll copy that here and put in my email, then click create. And now we'll get an error that the repository is empty, which is actually a good thing because that means they're connected. We can fix that by pushing something to our repository. Now, if you were to get an error here from permissions, this can be addressed by adjusting the permissions on your fine-grained token you created in GitHub. Now let's address putting something in our repository. To do this, let's go back to the GitHub repository from the instructions. The first step is to clone this Rancher Fleet repository to our own local machine. We'll copy this command and paste it into command prompt. Then the next command just simply confirms that this directory exists, then changes the directory back to our local user. Then next, we'll create a second folder on our computer called New Repo. And we have a README file that got populated in this folder. Next, step 4 is a little tricky. We'll first copy this section of the command rather than copying the whole thing, because we need to customize this line here. Then we'll hit enter on this last line. Then we'll go back to this command here, copy it. And before hitting enter, I need to change it to my own user. And this is my GitHub user, not my local machine user. Now I can copy this last command. And we see it pushed that README file to our new repo. So now I can go back to this tab here and hit refresh. And we see that there is a new README file. Now we'll go back to the GitHub instructions. And now we're at a point where we need to manually copy files as needed to the Rancher Fleet repo into that new folder so that Rancher can pick it up. So let's check on Rancher. And it still has that error because we don't have anything to deploy yet. And the reason we still have this error is we have a README file, but there's no instructions yet to deploy anything. So we can fix that by copying an init test file. So we'll go to Rancher Fleet and then go into this init test folder. And then we will copy this make namespace.yaml file. And if you wanted to see what it does, we could just open it real quick. And simply all it does is it says, here's a new namespace. So we will copy this and paste that into our new repo folder. And before I push this to our remote repository, we can see that we currently have a namespace called Nextcloud. But what this YAML file will do is deploy a new namespace called Nextcloud 2. We can go ahead and push that to our remote repository. I'll copy a command here. So that is now pushed to our repository. We can hit refresh and we can see that it got pushed. All right, so we can see that it picked up one resource. If we click on that resource is a namespace, and we can even confirm that kubectl get namespaces. And we can see that we have a Nextcloud 2 namespace. Now I can go to File Explorer and delete that YAML file from my local machine. Then go back to the command prompt and say git add and a dot, then git status, and it shows that it did see that this file was deleted. And then I can say something like git commit -m test file. And then I can say git push origin main. And now that file is deleted. If we went to GitHub and hit refresh, we can see that file is no longer there. There we go. Now we have that error again. Now we can go back to our instructions GitHub. So we just performed step 7, and now we need to do one other prerequisite before we can continue on to step 8. So this other prerequisite is that we have to have resolvable DNS. We know we have resolvable DNS for our nextcloud.yourexample domain, which is here. But we need to have resolvable DNS for your example domain too. So we need to run script 5a again, which was a few videos ago, but this time with a 2 at the end of the domain for yourexampledomain2.com. So we'll go back to our Proxmox shell, and I can type in ls, and then I can type in nano, copy the name of script 5a, and then we will scroll down and change the domain name here to 2 and hit save. Now I can run it. And to clarify, this will add a second DNS entry to our DNS server, which is on our admin VM. I'll go ahead and hit yes, and I'll hit yes again. And what this means is nextcloud.yourexampledomain2 will resolve to this IP, which is the third IP in our load balancer range. Now we can go back to our GitHub instructions, and now we can copy our files. So we're going to copy all 7 of these YAML files, and we'll paste them into our new repo. Now all YAML files 1 through 7 can be deployed at once. Their dependencies are handled by their names, 1, 2, 3, and so on, so that way each one builds on the next. How we deploy things using a pipeline is a little different than how we deployed things using a shell script. Certain things such as passwords stored in variables aren't available in the same way. I can explain more what each one does. YAML file 1 creates the namespace and then creates the RBAC permissions, also known as role-based access control permissions, for a deployment to be able to create and use what's called a Kubernetes secret. That way we'll have the ability to define a password for a MySQL instance later when it gets deployed. File 2 runs a batch job that actually generates the Kubernetes secret. There are certain password requirements for the MySQL instance database. The secret is 12 characters long, has capital and lowercase letters, and at least 1 number and 1 special character. Then this gets base 64 encoded. Then file 3 deploys the MariaDB MySQL installation as a blank database deployment. This MariaDB installation has persistent storage and gets its root password from the Kubernetes secret created from the previous step. File 4 runs another separate batch job pod, which customizes the database set up in MariaDB by creating a new database called Nextcloud with a user called Nextcloud, and also uses that same root password that was our Kubernetes secret, calling it MariaDB secret. File 5 is the big complicated one. This actually deploys Nextcloud with persistent storage and connects it to our MariaDB instance with our new Nextcloud database. But one problem is that our config file needs to have that trusted domain added and use HTTPS like we saw in our other video. We need to be able to customize the config file. And we can't run a separate batch job because that pod would require permissions to log into this one and modify this Nextcloud pod. Instead, we use what is called a sidecar container, in which we have a secondary container in the same Nextcloud pod that runs to check the configuration files and ensures through a shell script that the config PHP file has the correct content. Then we're back to simpler YAML files, where file 6 creates and assigns a self-signed certificate for our new Nextcloud instance. Then file 7 creates and applies an ingress resource to expose the Nextcloud deployment on our LAN via HTTPS using that self-signed certificate. Now that all our files are here, let's push them to our GitHub repo and see the deployment in action. I'll go back to our set of instructions and we can scroll down and copy this and paste this in. And now in our GitHub, I can hit refresh and we can see all the files are there. And now in Rancher, we'll see soon that those resources will start deploying. It may take a moment for it to start to pick up on that change. Okay, it looks like it's starting. And of those 7 YAML files, we should have 16 resources. So currently we have 12, now 14 resources deployed, and pretty soon we'll get 16 out of 16. Okay, 15 out of 16. It may hang at 15 out of 16 for a bit. Awesome, we have 16 out of 16 deployed. But once it hits 16 out of 16, that doesn't necessarily mean our deployment is completely ready yet. There is some weirdness with the config file. We can browse to it, but it's not quite there yet. And so what we can do is say kubectl get pods in the namespace Nextcloud 2. It looks like everything is ready. Let's go back and hit refresh. All right, it just took a minute. So now I can hit admin, change me for the password. And it usually does this on that first login. And here we are. We now have a Nextcloud instance with persistent storage. We can also see if I was to click the admin profile here and then go to administration settings, go to system, and scroll down, we can see that this is a MySQL instance. Pretty cool. If I was to go back to our YAML files, I wanted to show that in this scenario, the Nextcloud deployment currently is set to use, I believe, 5? Yes, it's set to use only 5 gig of persistent storage because I still wanted to keep the existing deployment alive that I had. So we don't have a ton of space for our persistent volume, and a MariaDB, I think, is still using its default 8 gig, yes, 8 gig of storage for its database. So a little wonky as the database is bigger than the size where we could actually deploy, but those could be easily adjusted in the YAML files. And we can actually go back into Rancher and then go to our Longhorn and see some more statistics on things that got deployed. So if I was to go to volume, we can see all of the persistent volume claims that we have. So we have still the Nextcloud persistent volume claims, but we now have these Nextcloud 2 persistent volume claims. I think we got lucky with our Nextcloud instance deploying pretty quickly and its config file also applying pretty quickly. In our Proxmox shell, when we ran the kubectl get pods, we could see all of the components deployed and they were ready. And just because these show that their state is ready doesn't necessarily mean that our Nextcloud pod is completely ready. If you remember, we have a sidecar container that is in this 5th YAML file that has to run and modify the config file. So it may not have completely run yet. The way to verify that is if we go back to the Rancher Fleet GitHub and I copy this command here, we can paste that into our Proxmox shell. And what this does is it gets this pod name, Nextcloud- this generated ID, into a variable called pod name, and then it'll log in as that pod. And we can see that it echoed out the config file here. And we can see that the trusted domain is there. And we can also see that it responds back as HTTPS with the overwrite URL as our trusted domain as well. If this didn't come back with a config file that had this information in it, well, we'd know that that sidecar container did not yet run. In testing this, I've found that after the first deployment, sometimes that Nextcloud pod may restart and then the config file goes back to its default settings. For this reason, I've set the shell script that the sidecar container runs to have a 3-minute waiting period, then check in a loop to modify the settings again. I have seen it take up to 5 minutes after being shown as ready for this configuration to fully show. And there you have it, a working Nextcloud deployment with persistent storage with a MySQL database instance deployed in a GitOps method. Thanks again for watching this series. I hope you learned a lot from this demonstration. I sure did, especially in making this presentation. Thanks again, and keep learning.